Hello. Hello and welcome to this video on C++. In this video, we will talk about inheritance, aggregation, and composition. So, inheritance is one of the primary features of object-oriented programming, where one class can derive from another class. The class which derives is called child class or subclass, and the child, and in other words, the class which derives is called derived class, and the parent class is called the class which it is deriving from is called base class. Similarly, the other terminology is base class and derived class. So why inheritance is important? So in object-oriented programming, or rather, let me talk a bit about C. So in C, the mechanism to do code to use is through functions. But in C++, you don't write plain functions as such. You write functions which are part of a class. Okay. So how do you make the code to use? So the trick is to use inheritance. The derived classes can call the methods of the parent class. Okay. So that is one of the main reasons why you need inheritance. Now there are three ways, or rather, there are 6 combinations of inheritance possible. I'll tell you what those combinations are. So you have 3 excess specifiers. So you have public, then this value can be this value will be always available to outside world. Then you have protected. This value will be available only to the child class, not to the outer world, and also to the class which has it. So base class can access all the values here in the methods or the class methods. But outside world can access only pub. Now protected can be used by the derived class, and derived class can also make use of the public part, but derived class cannot touch the private variable. Okay, that is the rule. So if you take, now we talk about this keyword, this public, protected, and private. So when you have this modifier or qualifier before the name of the base class, if it is public, then public and protected members will come to the derived class as public and protected. If it is protected, then public members will become protected in this, and protected will remain protected. Private will just won't come in the derived class. Then the third thing is that if it is private, then in this class, public will become private and protected will also become private. I will have to show you one more level of class to show this. Okay. On the third level, it will be very clear that how it works. So that I will leave as an exercise to you. So this is public specifier, pub is public, prot is protected, and priv is private. Now we create a derived class with public. You can access public and protected. These are fine. And the protected mechanism, still you can access public and protected, but they are protected variables now. Not pub is no longer pub. And if you take private, then this pub and prot will become private. Okay. So let me show you one more class, third level, and I will take, for example, public from private derived. Okay. And let's see public, and then we will do word show, and we'll try to access these two. Let's see whether we can access it or not. You come here and paste it. Okay. Now you see the uh, compiler's extension, which is C++ extension or LSP server rather, gives an error. It is inaccessible, can't access it. Okay, because these have become protected, private. And the private derived, they became private, so you can't access it, as you saw from the LSP. So it won't work. Okay. Now let me add one thing here which is missing. It is return zero. So now we see that we have the derivation. The second thing is that you can have multiple parent classes. You can inherit from multiple parent classes. That we will discuss in the next video, not in this video. So now it is just a matter of running the code. You can access the public in the class PD, which is public derived, but in protected you can't access public and you can't access private derived in private derived class. So let's see, we run this. I have already compiled this program, and you can run the program and you can see it printed 10 for this. Okay, and I need to show you more. I can say pub, not pub, base class object we have not created, right? We have pd public derived dot show. We will do public derived dot show. We will do protected derived dot show, and we'll do private derived dot show. Sure. Okay. So now we can compile again and we run this. Okay. So you can see and verify the output and see how this works. So since all outputs were given, that means the uh, variables are available in those. So in general, what happens, it is quite simple actually. It might be daunting, but it is quite simple. Most of the classes will not have public members, data members as such. Okay. The data members will be either protected or private. In general, it will be private. Some cases you will have protected. So the rule for now, the inheritance, when we talk about inheritance, will in general be public or protected. Rare cases you will see private inheritance. Okay. All right. But you can see private inheritance. We'll talk about these later as well. So with this out of the way, I will talk about two and one more thing I'll say, okay, before going on to the next topic. This relationship between derived and base, or child and parent, or subclass and superclass is called and is a relationship. Suppose this base class is vehicle, and then you have car or BMW. For example, you can make it car, you can have BMW, you can have Mercedes Benz, you can have say Volvo and all that. So the cars BMW is a car, Volvo is a car, so it is called and is a relationship. That is the terminology you will encounter. So it's a bit of jargon. The second jargon or concept is called aggregation. In aggregation, what you do is you have a class, okay, and that class will hold a pointer to another class's object. Okay, so here you see department holds the professor pointer of process. I will talk about a bit about vector. Vector is like an array, but it can grow and shrink. Okay, normal arrays can't grow or can't shrink, but a vector can grow and shrink. So that's what vector is. It is a just better array. Okay, and it gives you a lot of functions and methods to do operate with. Now let's look at a processor class. We have a private member name and then we set it using initializer list, and in the display we print the name. The department has a vector of professor pointers. That means multiple professors can be part of this any department. Okay, one professor can be part of multiple departments as well. For adding a professor, we do a push back. So at the end of the vector, it will add a professor pointer. Note that P is a pointer. Okay, and show professors, we iterate and show the professors. We call display command here. Now this display command you see has come from professors. Okay, this object pointer can invoke this method. Now we have Professor P1 Alice, P2 Bob, Department Computer Science. So we add Professor as a pointer and another as a pointer, and then we show it. Okay, let's see this in action. This is aggregation. And then we say dot slash a dot out and it prints the name. So aggregation you should in general avoid. The reason is this class is professor pointer. Now there could be multiple departments. Department here is generic. It could be a different object. One professor can be part of two different departments. Okay. Now if the pointer of this pointer is held by different classes, okay, and this pointer or this P1 and P2, if they go out of scope, okay, or they are deleted, then this class will never know. Department will never know that the pointer no longer exists. Okay. And particularly when you have complex architecture where there are lots of classes, lots of inheritance, then it's a problem. Okay. So in general, aggregation should be avoided. So what should we do if you want to do aggregation? If you really need to do aggregation, don't use raw pointers. Use shared pointers. Shared pointers can create cyclic links, so that can be tackled with big PTR. Those are smart pointers which we will discuss. For now, remember that you can use shared pointers instead of raw pointer of C++. Shared pointer is a ref counted pointer, so as soon as you pass it to another class, it increases the count. So we'll see that when we discuss more. So this is an architectural stuff and a lot of jargon is there around it. This relationship is also called has a relationship. Has a relationship. So department has a professor or department has multiple professors. Now we will talk about composition. So in composition, what you do is uh, in any class, they do not need to inherit, okay, or rather they necessarily don't inherit. In a class, you create objects of the second class. So for example, we have a room class which has two functions, constructor and destructor, so created and destroyed. Now we have house which has a vector of rooms. Now in the constructor, we pass how many rooms are there, and those house will be created. Okay, and so we have not filled the vectors here. Okay, we have just created the rooms with rooms. There should be private variable rooms. Okay, rooms are here. Okay, so these many vector will be created with this num rooms. Okay, so how many rooms are there? It will go in the house and so. So can we? I don't think this code is correct. Let me remove this. Rather, we say int number of rooms and we create that with that. I'm mixing two different stuff, snake case and camel case. Number of group and for I is equal to 0, semicolon I less than number of rooms. This should be unsigned int, and let's make this unsigned int. We make it unsigned int, okay, and we do plus plus, and we create a room R, and then we push it to the rooms dot pushback, and we push the room R. Okay, so now it will have that. So now we will have number of rooms in here. So this should call the constructor of the number of the rooms class, and as well as in the destructor this rooms will be destroyed. So we are creating 3 houses, and there should be 3 constructor call to rooms and 3 destructor calls. So we run this. Okay, sorry, this should be composition. Between unsigned int and int. Unsigned int and int, where did I make a mistake? I less than number of rooms. Number of rooms. Okay, this is int. Unsigned. Okay, this should work now, and we run this now. Let me increase the font a bit, and with a dot slash a dot out. Okay, so we have created house with argument 3. All right. So house is created, room is created, room destroyed, room created, room destroyed, room destroyed. 1, 2, 3, 4. Why this room is destroyed here? It is out of order. Okay. All right. So what is happening is it is going out of scope here only. Okay. All right. Let me see what is the problem here. Okay. These rooms are copied to the vector and then they are deleted. Okay. So what we can do is number of rooms. Okay, let's revert the code to the previous state. I might have made the mistake. So we have int number of rooms, and we have rooms with number rooms. Okay, I may have misunderstood that. Okay, so we have 1, 2, 3 rooms created. So first rooms are created because the vector object will be created, and then house will be created, and we destroy, and rooms will be destroyed. So this initializes vectors with 3 rooms. Okay, those rooms will call only default constructor. You can't call overloaded constructors here. So this will create those many rooms, and so first rooms are created, then house is created, and in the destruction the order is reversed. First house is destroyed, and then rooms will be destroyed. So in this case, the class house owns the rooms object. That is, rooms will live as long as house is there. When house dies, memory cleanup will happen for rooms as well. And it is called has a relationship. No, this is not has a. Has a is aggregation. Hang on, let me remember. Composition is has a. Aggregation is not is a. Is a is inheritance. Composition is has a. Aggregation is not called has a. I was wrong earlier. Okay. So this is has the relationship, and in general you try to use composition. The reason is there is no inheritance here. So your class diagram remains simple and there is strong ownership of rooms. So there is less chance of this getting messed up when you do code because there is no pointer maintenance here. So I think that covers the basics of inheritance, and I would I will end this video here, and in the next video we will learn more about inheritance, virtual functions and all. Okay. Uh, and one thing I forgot, yeah, third level I have shown here. I will remember it in the next video. Okay. So with this, I will end this video here. I hope that you are enjoying this playlist of videos on C++ and finding it useful. So I thank you for watching the video, and we will meet again in 4 or 5 days with a new video on C++. Till then, keep learning, and I'll take my leave. Enjoy. So, okay.